Hey there, Geometry Cats. Today we're going to be looking at 6.2, Similar Polygons. What does it mean to be similar? Let's get right into it. So similar polygons are really unique because they are the same shape but different. So they are the same shape but different size. Think about like if I build a model house, right? That model house will have the same roof pitch, and the walls will be the same ratio to the roof and the walls to the floor. But then when I go to the house I built, right? Same exact shape, not according to my drawing, but they're different sizes, okay? So polygons are similar if all the corresponding angles are congruent. So if I look at this house and all these angles are congruent, then those houses are similar. That means my model house is the same shape as my actual house. Okay? Different size, but same shape. And the other thing that has to be true is the corresponding sides are proportional. Uh-oh, come on now. Come on now. You can do this. What are you doing, computer? I'm keeping this in. Alright, that was wild. Sorry for the delay. So the corresponding sides are proportional. It's kind of like the scale of our model, right? Like if our house is a 10-to-1 scale. It means every foot on our model is 10 feet to the actual house. And that number is consistent for all parts because all the sides are proportional. And that's what we'd call the scale factor. Okay? And if they're all similar, that means their perimeters are also proportional. Alright, what does that mean? What's that going to cause for us? Good question. I'm happy you asked. Well, one of the first things we have to know how to find is let's find the scale factor. So what's the scale factor from ABC to DEF? So now to find the scale factor, how do I get from one to the other? Or what's the ratio of size? What's the proportional? So I'm going to put what I have on top and what I'm going to on the bottom. So for ABC, AB is going to correspond with DE. So my scale factor is going to be my 8 over 12. Which when I reduce, that's 2/3. This also means if I times any of these sides of DEF by 2/3, I should get my sides for ABC. 15 times 2/3 is 10. So it works. Okay. So now what if I want the scale factor the opposite way? What if I'm going from DEF to ABC? So I'm going from DE to AB. So I'm going to do 12 over 3. I'm sorry, 12 over 8. Which reduces to 3 over 2. So that means if I multiply any of the sides of ABC by 3 over 2, it'll get me to DEF. And now what if I'm asking for the perimeter? What about the perimeter? Well, the perimeter is going to be the same as this one. It's going to be 3 over 2. And I could prove it by adding them all up and dividing it by them all added up. But you don't need to because they're the same either way. Okay? Although order does matter. What your start, or the 2 goes on the bottom. Now, how would I make a similarity statement? What's the symbol for similarity? That's a good question. I'm happy you asked it. It's kind of like the negate symbol. Okay? Equals congruence. That's congruent, right? This is similar. Similar is just the top part of the congruent symbol. So up above, we would have said that triangle ABC is similar to triangle DEF. Order matters here. A and D better be the same angle. B and E better be the same angle. And C and F better be the same angle, or else I'm going to come to your house and call the angle police. Uh-oh, it's doing the thing again. It disconnected. Alright, let's pause it. Guess who's back? Back again. Alright, let's do one example, and we'll call it a day, actually. So we're looking at triangle JKL is similar to PMN. Awesome. So I need to find my congruent angles and my proportionate sides. Well, we've done this before with congruence, but this is similar, but it's going to be very, very similar. No pun intended, but appreciated. So angle J is going to go with angle P. Angle J is going to be congruent to angle P. Alright? Alright. K is going to be congruent to M. And L is going to be congruent to N. Just like how we did many sections ago. But now let's get tricky. Let's get wild on this one. Now before we said equal to for our congruence. This time we're not. We're going to do it a little bit. So instead of writing JK is congruent to PN, I'm going to say JK over PM is going to equal KL over MN. So I'm finding out which ones go on top of each other. And that's going to be equal to JL and PN. Now be careful in these, because I want you to notice something. I want you to notice that all these on the top come from the same triangle, right? And all these on the bottom come from the other triangle. Alright? Alright. Well, that's where I'm going to end it today. I hope you learned something. Maybe, maybe not.